The next time you buy a canned soft drink, consider this. That aluminum can will always be recyclable. Unlike plastic, aluminum never deteriorates, no matter how often it's melted down and used again. Aluminum cans are so lightweight that it's hard to believe they're made from a huge roll of aluminum sheeting that weighs 9 metric tons. The sheet is about 1.5 meters wide and as thin as construction paper. A roll like this is long enough to make 750,000 drink cans. The sheet feeds into a press that punches out round pieces that'll be formed into cans. The punch press actually performs 2 operations. It punches out a disc 14 centimeters in diameter, then bends it into a cup. What's left of the sheet gets compacted and sent back to the aluminum factory where it's recycled into new rolls. The cup goes into a machine called the draw and iron body maker. A tool draws out the aluminum, forming the body of the can. The tool is lubricated so it won't tear the aluminum while stretching it. The lubricant also acts as a coolant because the aluminum heats up as it's being worked. Once the body is formed, a trimmer cleans and straightens the edge. Now the cans move along upside down on the conveyor belt over to the washer. The washer performs a 6-stage cleaning. The first 2 washes are in hydrofluoric acid at 60 degrees Celsius. The last 4 washes are in deionized water, neutral water with no pH, also at 60 degrees. The cans come out of the washer and go under a hot air dryer. They're now shiny because the hydrofluoric acid wash removed a thin surface layer of aluminum. Next, a roller passes over the cans, coating the bottom rims with varnish. This varnish coating allows the cans to slide easily on conveyor belts and in vending machines. It shows up as a blue ring under ultraviolet light. The cans are now ready to be printed. This rotation printing system can apply up to 5 colors, one at a time. The machine then applies a layer of varnish to protect the ink. This is what the print and varnish process looks like in slow motion. And here's the actual speed, 1,800 cans per minute. Next, the cans fly through an oven that instantly hardens the ink and dries the protective varnish. The next machine sprays a water-based varnish on the inside of the cans. This creates a barrier between the drink and the aluminum, so the drink won't end up tasting like metal. It also prevents the aluminum from being eaten away from the inside by the acid in carbonated drinks. Next, the cans go through a machine called the necker, which forms a 5-centimeter neck on the can. This is done gradually in 11 steps so as not to puncture the paper-thin aluminum. The next machine, called the flanger, forms a curved-over edge at the top of the can, which will later attach to the pull tab cover. The cans pass through a sophisticated vision system that photographs the inside of each can. Any can that doesn't meet standards, that has a bump or ink inside, for example, is automatically canned from the production line. They strap the finished cans onto a pallet. From here, they're shipped to the drink company, which fills them, then attaches the pull tab cover. Clothes dryers were invented in Europe in the early 1800s. The lady of the house would put the clothes in a metal barrel with holes in it, then turn it by hand over the fire. The first electric dryers were invented around 1915. Most of the parts are made from steel, just 3/4 of a millimeter thick. The factory receives it from the supplier in giant rolls. They go onto a machine that cuts sheets about a meter long. Using those sheets, industrial presses stamp out various dryer parts. These are motor supports. And this is the back panel of the drum, the rotating compartment that holds the clothes. Note those small holes. We'll come back to them shortly. To form the side of the drum, the machine bends a sheet of pre-painted steel into a circular shape. When a clothes dryer operates, it sucks in outside air through a hole at the front. The air passes through the heating element and goes into the drum, entering through those little holes you saw a few moments ago in the back panel. Once the automated machines have finished shaping the drum, they form a groove on its outside surface. This groove is for the motorized belt that drives the drum. Next, they put the drum on another machine that screws 3 baffles in place. Baffles are those thick plastic wings located inside the drum. They're what throw the clothes around as it rotates. Back on the automated line, the drum's front rim goes on. They manually assemble the drum's back panel. Then a machine installs it. Next comes the exhaust duct. Hot, moist air exits the drum through a bunch of holes and a large slot in the dryer door. The air gets channeled downward through the lint screen, then goes through a duct at the front of the dryer to the fan. The fan blows the air out this exhaust duct at the back of the dryer. The dryer's heating element works much like the element in a toaster, except it consumes a lot more power, up to 6,000 watts. The factory receives the steel and ceramic heating coils ready-made. Workers simply position them on a sheet of galvanized steel. They also install a temperature sensor that shuts off power should something go wrong and cause the dryer to overheat. In the finishing department, they coat the dryer with powdered paint that's heat and shock resistant. Then they assemble the bottom and back of the appliance. They install the motor that drives both the belt and the fan. Then the exhaust duct goes in. Automated machines prepare the electrical wiring. They paint and cut the wires, then install a terminal on each end. Workers wire the dryers, then install the drum. They close up the sides, screw on the door, then wire up the control panel. It's connected to a series of gears and switches that control the dryer cycles. The model and serial number sticker marks the last stop on the assembly line.